So this problem reads, use the sample data and confidence level given below to complete parts A through D. So a research institute poll asked respondents if they felt vulnerable to identity theft. In the poll, N equals 949, X equals 560, who said yes. Use a 90% confidence level. And it says click the icon to view a table of z-scores. I am not going to do this. I am not going to use tables. So we're going to be using StatCrunch and or the TI-8384. Okay, so the best point estimate. So if I can only use one value to sort of approximate the number of people that feel vulnerable to identity theft, what would it be? Well, and we're looking for a proportion. It would be this 560 over 949. That is my point estimate. We call that p hat. And p hat equals x over n. So it's going to be 560 divided by 949. And we're going to get a decimal. It says run to 3 decimals. So I get 0.590. And if you are going to be doing a lot of these, and we have lots of rounding to 3 decimal places, you can change that mode and then scroll over or down to float and going out to 3. And now when I redo that one, it goes ahead and rounds it to the number of decimal points I specified, in this case 3. So 0.590. Simple as that. Okay, part B, identify the value of the margin of error, E. Now, I'm actually going to do part C first. The way they're wanting you to build this is if you were doing this by hand, which we're not going to be doing these by hand. So we are going to go ahead and use either the TI-8384 or StatCrunch. So in the question help, click question help and click StatCrunch. Okay, StatCrunch should open up. We're going to go to stats. This is a proportion. The two big things we're going to have in here are means and proportions. And so for proportions, we're going to go to proportion stats. We just have one sample, right? And we have 2 choices. With data, if we were given a list of all the data, we'd do that. With proportions, we're often given the summary statistics. So we're going to select summary. Now the number of successes, that was 560. And the number of observations was 949. And I've forgotten the level of confidence. It says use a 90% confidence level. So we need to keep that in mind. So I'm not running a hypothesis test. We'll do that in a subsequent lesson. Going to do confidence interval, and let's change this to 90. Now in this class, we're going to use the standard walled confidence interval. In future classes, you may be using the egress-D. And we'll just leave it everything as is and press compute. Okay, and so we notice we get the p hat here, 0.590, which we already did. Standard error. And here's our lower limit, 0.564, and the upper limit, 0.616. So let's write that down. So that is my interval. Now, recall from an earlier lesson, if we want to convert this into a plus-minus notation, remember the plus-minus is p hat plus or minus my error. And that's kind of what they're trying to get you to do, except our technology does not spit out the plus-minus. It gives us in this interval notation. Or in a just upper bound. Here's my lower bound at 0.564 and the upper bound 0.616. The TI calculator will give you exactly the same thing. Let me show you that. So on the TI, I'm going to go to Stat, Tests, and this is a 1 prop Z interval. Right there, A. Notice we have exactly the same input we had on StatCrunch. Our X was 560, and our N was 949, if I'm correct. Yes, 949. Confidence level, you'd hate to miss it because you missed this one. You can put 0.9 or you can actually put 90. Notice we get exactly the same thing, 0.564, 0.616, and it even gives us the p-hat, which we figured by hand anyway. And it reminds us that our sample size is 949. Why does it say 0.000? Earlier, I had changed my mode to round to 3 decimal places. I can change that back to float if I want to. Let's just leave it at 3 for now. So recall what I did to find the p-hat was I averaged these two values. I'd say 6.16, 0.616 plus 0.564 and divide by 2. I already have p-hat. I don't need to do that. Although it's sometimes useful to do just so you remember 0.590 is smack dab in the middle of this interval. To find E, what did I do? I subtracted these two and divided by 2. And when you do that, you get 0.026. So I just checked the answer, and it wants it to 4 decimal places instead of 3. So on StatCrunch, rather than 0.564, I need to take it out one more place. Okay, and same thing for the upper limit, 0.6164 instead of 0.616. So we would just need to go out one more place, subtract those, divide by 2. And you will get the 0.0263 instead of 0.026. And with the confidence interval, they went to 3 places, so 0.564. And I'll let you think about the statement that correctly interprets the confidence interval. We've talked a lot about that in some of the videos and in the textbook, so try to internalize that, okay? I hope that helps.